Hello guys, good evening. It's evening here, so that's why I'm saying good evening. Welcome for another question from inverse trigonometric functions. This is a proving question and let's see what do we have here. We have sine inverse 8 by 17 plus sine inverse 3 by 5 on the left hand side, and on the right hand side we have tan inverse of 77 by 36. Looking at the question, I immediately got the idea that we have to convert both these sine inverse terms into tan inverse terms, and then we can apply our formula of tan inverse x and plus tan inverse y. We can apply that formula that's given in the NCERT. So let's move further without further ado. Okay, let me show it first by my approach, triangle approach. Actually, it's not mine, I just call it triangle approach. I don't know what's the name of this approach. Okay, so we have sine inverse 8 by 17. So sine inverse 8 by 17 can be represented as perpendicular is equal to 8 and hypotenuse is equal to 17. Using Pythagoras, the base becomes 15. How? Root 15 is equal to root of 17 square minus 8 square. Solve this expression and you get your answer as 15. Okay, so now we have sine inverse of 8 by 17 as tan inverse 8 by 15. Let's see how they have done it. Okay, so what they did? They took sin x is equal to 8 by 17. Then they applied the formula of sin square x plus cos square x is equal to 1. They find out the value of cos x. The value of cos x is equal to 15 by 17, and they found out tan x is equal to sin x by cos x, as we already have the value of sin x from here, cos x from here. So their tan x comes as 8 by 15. So their x is equal to tan inverse 8 by 15. This must be tan x. There is a mistake here. Here. This is tan x actually, not tan inverse x. Okay. So tan x is equal to 8 by 15 and x is equal to tan inverse 8 by 15. Now moving to the next step. Okay, so we have our second term as sin inverse 3 by 5. We need to convert it into tan inverse. So let's do the triangle again. This is a perpendicular, 90-degree angle. This is a right angle triangle. So sin inverse 3 by 5 can be represented as perpendicular is equal to 3 and hypotenuse is equal to 5. By the Pythagoras theorem, we have base as 4. So sin inverse 3 by 5 can directly be written as tan inverse 3 by 4. So we have simplified now both the terms. So what's our next step? Our next step is that we take our LHS. Our LHS was sin inverse of 8 by 17 and plus sin inverse 3 by 5. So what we do now? We replace the corresponding tan inverse terms of both the sin inverse and 8 by 17 and sin inverse 3 by 5. We replace both these sin inverse terms by their corresponding tan inverse terms. So what do we get? We get tan inverse of 8 by 15 plus tan inverse of 3 by 4. Next, we apply the formula tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy, where x is equal to 8 by 15 and y is equal to 3 by 4. So simplifying the expression, we get tan inverse of 32 plus 45 upon 60 minus 24. Further simplifying, we get tan inverse of 76 by 36, which is actually equal to what's given in the RHS in the original question. So we can see that we just proved LHS is equal to RHS and our problem is solved. By problem solved, we mean that we just proved that our left hand side was equal to right hand side. I hope you all understood it. Thank you. Bye.